Hello everybody, myself Shreya from EB14 of CSC. I would like to explain about the topic regular grammars. Let us see what is regular grammar. The regular grammars are either left or right. Right regular grammars, we'll see the rules of the forms A tends to epsilon, capital A tends to small a, capital A tends to small a, capital B. Here we can see that capital A, capital B variables and A small a is the terminal. Left regular grammars. Rules of these forms include A tends to epsilon, capital A tends to small a, capital A tends to capital A, small b. Capital A, capital B are the variables and capital A is the terminal. Now let us see the example for this regular grammar. We can see that S tends to small a s or small b capital A, and A tends to small c capital A or epsilon. This grammar produces the language produced by the regular expression A star BC star. Let us see in how many ways it can be written on. S can be written as AS and then S can be written as AS. So we can see that it is small as. Again, S can be written as small b capital A and capital A can be written as small c capital A. Again, capital A can be written as small c capital A. We can see that we'll be getting small a, small b, small c and capital A. We can see that it can be written as small b, small c also. We can see that we'll get small c. The right regular grammars are producing the regular languages. We'll show that right regular grammars are equivalent to NFA epsilon. And let's see how it can be done. It can be done in two directions. Given a right regular grammar, construct an NFA epsilon that recognizes the same language with right regular grammar. Given an NFA epsilon, construct a right regular grammar that describes the same language with NFA epsilon. Right regular grammar, NFA epsilon. Suppose that I have the right regular grammar as capital V, sigma, capital R, capital S. I construct an NFA epsilon which includes Q, sigma, delta, S and a final state. Set of states Q will be set V union final state, where F is a new symbol denoting the final state. Productions in R have three possible forms. A tends to epsilon, adding the transition state will be getting the final state. And A tends to small a, capital A tends to small a, add the transition state and we'll be getting the final state. Capital A tends to small a, capital B, adding the transition, will be getting the capital B. Now let us see NFA epsilon right regular grammar. Suppose that I have an NFA epsilon which includes the states Q, sigma, delta, Q naught, capital F. I construct a right regular grammar Q, sigma, capital R, Q naught. For each transition state Q and small a, Q, comma, I construct the rule Q, AQ in R. Furthermore, for every state Q initial state in final, I add a rule Q initial tends to epsilon in R. Let us see the examples. And we have the question, transform the following right regular grammar in an equivalent NFA epsilon. You can see that S tends to small a capital S or small b capital A and capital A tends to small c capital A or epsilon. And we have the solution as as there are three states, we have the three states in which two states are normal and a final state. You can see on giving the input small b to S, it goes to A and A is a self loop for S. And on giving the input of epsilon to capital A, will be reaching the final state, and on inputting C to the capital A, will be reaching the A state itself. Now let us see some of the examples of transforming DFA to a right regular grammar. On inputting small a to Q0 will be reaching the final state Q1, and on inputting small a to Q1 will be reaching the final state Q1. On inputting B to Q1 will be reaching Q0, and on inputting B to Q0 will be reaching Q0. And we can find the solution that Q tends to small a Q1 or small b Q0, and Q1 tends to small a Q1 or small b Q0 or epsilon. Left regular grammars. It can be proved that left regular grammars also produce the regular languages, but this is not so straightforward. Actually, a left regular grammar produces the reverse of the language produced by the right regular grammar, in which we reverse the rules capital A tends to capital A small b to capital A tends to small a capital B. But the set of reversed languages of all the regular languages is exactly the set of regular languages. So the left regular grammars produce the regular languages. We can see that the derivation of the small ABC is capital C tends to capital B small c, and capital B can be written as capital A small b, and capital A can be written as small a. So it can be derived in that way. Or else capital C can be written as small c capital B, capital B can be written as capital A small b, and capital A can be written as small a. So I should start creating the string ABC from right to left. But this is equivalent with creating the reverse of CBA. We can see that capital C tends to small c capital B, and capital B can be written as small b capital A, and capital A can be written as small a, and then we take the reverse. We can see that the right regular grammar with the rules of the form capital A tends to capital B small a reversed is capital C tends to small c capital B tends to small b capital A tends to small a. It produces the reverse language. So just create the NFA epsilon for the language produced by the right regular grammar, and then compute the reverse. Change start with final state and reverse the arrows. This is an NFA epsilon for the left regular grammar. I hope this is helpful. Thank you.